So in our previous grades, this topic was normally termed as or named as number patterns. Okay. So what we're going to start with is revisit what we did in the previous grades, especially grade 11. So under number patterns, we have 3 types. So under sequence series, there are 3 types of patterns that we're going to focus on. The first one is what we call the quadratic. Okay, the quadratic patterns. Then we're also going to look at the arithmetic patterns. And then lastly, we shall talk about the geometric patterns. Okay, we shall try to be as detailed as possible. Okay, so starting with the quadratic, we know that the quadratic patterns are just linked to the parabolas. We know that the general term of the quadratic is given as an squared plus bn plus c. So we know general term will also be known as, let me just call it general term. Okay, general term will be called the general rule, or sometimes it can be called the formula for determining that particular pattern. What we know about the quadratic is that it has 2 differences. Okay, we have the first difference, and then we also have the second difference. Now, the first difference forms what we call a linear pattern or an arithmetic pattern. And then the second difference is what is constant. Okay. So let's say we have a basic example. No, before we get into the examples, let's just use the general rule. Let's say we want to determine term number 1 from this general rule. So I'll just substitute n with the 1. That will give me a plus b plus c. And then if I look for term number 2 where there is n, I'll substitute it with a 2. So that will be 2 squared. That will give me a 4a plus a 2b plus a c. Then what if I obtain term number 3? So 3 squared, that will be a 9a plus a 3b plus a c. And then lastly, let me get term number 4. So 4 squared will give me a 16a, and then 4 times b, that will be a 4b plus a c. Now I'm assuming these are my terms. Okay, term number 1, term number 2, term number 3, and then term number 4. Then if I get the first difference between these terms, remember, for us to get the difference, you subtract the consecutive terms. So I'm going to say term 2 minus term 1. So my 4a minus 1a, that's going to be 3a, and then 2b minus a b, that's just going to be a b. The c's fall out. And I get the difference here, 9a minus 4a, that gives me a 5a, then 3a minus a 2b, it will be a b, and then this c, and that c will fall out. I do the same thing here, 16a minus 9a, that is 7a. Then 4b minus 3b, that's a b, and then the c's cancel themselves out. Then let me try to get the second difference from what I obtained. So 5a minus 3a, that is just a 2a, b and a b will fall out. Same story here, 7a minus 5a, it will give me a 2a. So that goes back to what we say, that the second difference, which is the 2a, will be constant. And the first difference will form an arithmetic or a linear pattern. So when we are determining, let's say, the general term of any given quadratic, we always relate the second difference to the 2e. And then we use that second difference to find the value of a. Then we get the first term of the first difference, and then we relate it to the 3a plus b. And then lastly, we get the first term of the quadratic, and then we relate it to the a plus b plus c. We equate them. So in that way, we shall be able to determine the value of a, b, and c, so that we have our general term. Okay, so that is to do with the quadratic. Okay, but as we work along with the quadratic, we shouldn't forget the quadratic formula, because at some point we also gonna need to use it. Quadratic formula, remember, it's negative b plus minus. We have b squared minus 4ac divided by 2a. We're going to use this in determining especially the positions of the terms and all of that. Okay, then let's talk about the arithmetic. Arithmetic, sometimes we call them the linear patterns. So with these ones, we can start with the general term, which is given as a plus n minus 1 into d. Okay, we know that a represents the first term, and then d represents the common difference. The n will be just the position of the term within the sequence or within the pattern or the progression for that case. So let's say we have T1, it's A. Then our T2 is going to be A plus D, since we are just adding a common difference. And then T3 is going to be A plus 3D. So if you carry on and extend all of this, you'll end up with this. So this Tn will also represent what we call the last term within the progression. And then lastly, we have what we call the geometric sequence of pattern. Okay, general term of this, the general term of the geometric is given as AR n minus 1, so the exponent of n minus 1, where we still know that our A will be the first term. Okay, and then R will be what we call the common ratio. So looking at the arithmetic, for us to get the difference, remember, we subtract the second term and the first, and subtract the third term and the second. In other words, we determine the difference between the consecutive terms. Okay, you can have a T4 minus a T3, which is the same as a T5 minus a T4, and so on and so forth. Whereas with the geometric, for us to get the ratios, this ratio will be T2 over T1, maybe T3 over T2, T4 over T3. In other words, we are dividing the consecutive terms. So for us to determine the different terms of the geometry, we just multiply the previous term by a certain constant number. Okay, so that is to do with the geometric. Now, still these patterns have what we call the sum or the summation. Okay, the sum of patterns. Sometimes we can say progression, or you can even talk about the series. So when you talk about the sums, like if you're given a certain number of terms in a progression or a series, how do we determine the total of all those terms combined together? So we have various ways of doing it. Let's say for the first case, which is the arithmetic. Okay, so this will fall under what we call the finite series that come to an end. Okay, if our first term is given as A, the second term is given as A plus D, the third term is given as A plus 2D, and so on and so forth. And let's say our last term is given as A plus n minus 1 into D. Let me just use L. Will that make sense? Not going to make sense. Let me just say just L. as my last term. Okay, where I'm saying L is the same as A plus N minus 1 into D. So this can be my equation 1. So in other words, I'm saying my Sn is going to be all of this, the sum. I'm adding up everything. A plus 2D plus so on and so on plus L. Then I can flip around. If this is your equation 1, I can flip it around and start with the last term. So I'll have my L plus whatever follows, and then I'll have my last term, which is going to be just A. So that is still Sn is equal to that. Then when I plus the 2, I'll just have 2Sn is equal to A plus L. Okay. Then then from there I can divide both sides by 2, which means my Sn is going to be, I'll say A plus L. Everything is over 2. Can put this in brackets. But then we said our L was A plus N minus 1 into D. So let me just resubstitute that. And so A plus N minus 1 into D. I'm dividing this by 2. So that brings us to, so we just have 2 just like terms there. So it's just going to be 2A plus N minus 1 into D over 2. Now, since we're talking about a certain number of terms that we don't know, then we just have to multiply this thing by N. So that it is N over 2 into 2A plus N minus 1 into D. So this becomes the sum of the arithmetic. So this is always given on the formula page of the question papers. Okay, you just need to remember this. Then for the geometric, with the geometric, you don't need the proof, but you can go over it. You know that Sn will be given as A into 1 minus Rn over 1 minus R. So we use this sort of format if our R is it greater? No, if the R is less than 1. And then it can be flipped around and say A into Rn minus 1 over R minus 1 if the R is greater than 1. So this is just the sum of the geometric progression. So a quadratic usually doesn't have the sum. If ever you ask a question for the sum of a quadratic, which means the terms will be just a few that you can manually put into the calculator and get that. Then when you talk about the infinite series, okay, so these are basically series that do not have an end. So sometimes we call them converging series. Okay. So with converging series, there's a condition. So the condition for series to converge is that 1, they have to be part of the geometric progression. And then the common ratio has to be between -1 and +1. So this is the condition. And it's usually asked, like for which condition or for which values of R will the sequence or will the series converge. So you have to just state this first as the term of reference and then do the substitution of the R to get what you want. An example, if let's say we're given X as the first term, and then we have X squared over 2 as our first term, as our second term, sorry. Oh, this makes sense. And then we have X cubed over 4 as our next term. And then they ask you, guys, does this form a geometric? Yes, so our common ratio is just x over 2, if I'm not mistaken. Yeah, it's just x over 2. So if they ask you for which values of x or for which values, for which values of x will the progression or will the series converge, get your r and then substitute this r into there. So it's -1 is less x over 2 and is less 1. And then multiply through by 2, that you have a -2 is less x and it's less 2. So for values of x between -1, +2, that's when this progression will do the convergence. So when series converge, they also have a special sum, which we normally call sum to infinity. So this will always be given as S with an infinity symbol. And the formula for this is just A over 1 minus R, where A is still the first term, and then R becomes the common ratio. So for as long as you have your first term and you have your common ratio, then you're good to go in calculating the sum to infinity. Okay. So that is to do with just the basic introduction. Okay. Then we have what we call and what's that thing? It's called the sigma notation. Okay. So sigma is given as, I don't know, it's represented with this sort of symbol. It's either that or a funny E, funny looking E. And the meaning of it is just summation, which means sum. Okay, so what we know about the sigma notation is that it will be represented using one of these, and then there'll be something down here, which will be like the starting point. Okay. And then at the end part, that's where the end will be. In other words, they will tell us if we are given a certain progression, or let's say we have a general rule of maybe 2n plus 1. And then we say sigma 2n plus 1. And then they tell you starting with n may be equal to 1 up to, let's say, 99, something like that. So they're telling us that we should start at a point where n is 1. And then we should stop at a point where n is 99. Now, for us to get the number of terms, okay, number of terms of this possible progression, you get the end minus the start, and then we plus a 1. So in this case, it would be 99 minus 1, and then plus 1, which means in this case, we have 99 terms for this particular progression. It's also important for us to determine what sort of progression is it. Could it be arithmetic or geometric? Okay, so how do we do that? Just try to substitute the n's, at least for the first 3 terms. Okay, so let's say n is 1, n is 2, and then n is 3. And then we determine what sort of progression. But someone can also look at the nature of what is given within the sigma notation. Okay, so that is to do with the sigma notation and how it works. Or someone says we should prove the geometric sum. I know it's fine, we can do that. Okay, the sum of the geometric, how do we do that? Remember, I said the general term is given as a r to the exponent of n minus 1. Okay, so we can say that if our sum is given as a plus, the second term is going to be ar, the third term is going to be ar squared, and so on. And I can say plus. Now I need to determine what follows. Okay, so my last term is just going to be ARN minus 1. Then what I'm going to do, I'm going to multiply the first equation by R. I'm going to say 1 times R throughout. So that's going to be RSN is equal to, give it as AR, that's going to be AR squared plus 2, just continue, then I'll have ARN minus 1. And then when I multiply this by R, I'll end up with just AR to the N. That is my equation number 2. And then from that point, I may have, okay, I can swap it around. Then I have RSN is equal to ARN plus ARN minus 1, and so on. And then I'll end up with just AR. And then I'll have to add these two. Do I have to add? No, it will be subtraction. Can't be an addition. It has to be subtraction. So then if I have SN minus RSN, that will be SN minus RSN is given by A minus ARN plus, now this is going to be AR minus that whole thing and so on and so forth. And then I'll end up with ARN minus 1 minus AR. Okay. When I factorize out what is common on the left, I have just SN into 1 minus R is equal to, I'm just going to consider this first part, which is A into 1 minus R to the N, because it's going to be the same scenario throughout. Then I can divide both sides by 1 minus R. So A into 1 minus Rn over 1 minus R. Alternatively, if people just chose to work with this directly, yes, you can do the subtraction and what you can see that A is common, you'll be left with 1 minus R, and so on and so forth. But since we're talking about a certain number of terms, and then the N will come into play. So that is the proof of the sum of the geometric. So we've looked at the sum for the finite and the sum for the infinite sequences or series. Now, still under the sum, it's possible for us to determine the terms, okay, but using the sum. What does this mean? If we have, let's say, the sum formula or equation of a certain progression, and then they want us to determine the particular terms or the values of each individual terms, we know that T1 will be the same as S1. The sum of the first term will represent that term. Now I'll use an example. If I have 1, I have 3, and then maybe I have 5, then I have 7. Let me just use this as my progression. So this first term, the sum of the first term, will be the same as that. So I'll even call it A. Okay. Then for me to get term number 2, I must get the sum of the first 2 terms minus the sum of the first term. So which means if I add 1 and 3, that will give me 4 as my S2. But then I'm subtracting the first term, which is 1. So 4 minus 1 gives me a 3, which is that. Then for me to get term number 3, I'll get the sum of the first 3 terms minus the sum of the first 2. So in other words, we subtract the sum of the consecutive terms. Okay. So if I look at the sum of the first 3, 1, 3, and 5, that will be a 9. Minus the sum of the first 2, I end up with a 5, which is here. So in general, or in conclusion, we could say that for us to get the Tn, you must get the Sa minus the S of n minus 1. So this we also need to remember. then it's still possible for us to answer questions of simultaneous equations under these sequences and series. We just need to be alert with what the question is asking for and how to go about it. Okay, I think basically that's all we have to say about the sequences and series. So remember, for arithmetic, it's a plus n minus 1 into d. You have to know the definitions of a and d. And then for the geometric, we said it's a r to the exponent of n minus 1. Okay. And then for us to get the quadratic, we said it's a n squared bn plus c. This we just have to remember. Okay. Then the sums. Okay, the sum of an arithmetic, we said n over 2 into 2a plus n minus 1 into d. And then the sum of a geometric to be given as a into 1 minus rn of 1 minus r, or the other way around. Then the quadratic, you know, I don't have the sum. And the sum to infinity, we said it's a over 1 minus r. So this, we just have to remember all these ones as we work with the progressions. Okay, so let's have just examples. Please don't mind the numbering. Okay. So the first question is telling us that the following arithmetic sequence is given. We have 20, we have 23, 26, 29, and then 101. Then the question is asking us, how many terms are there? So for us to get the number of terms, one, they've told us that this sequence is arithmetic. Okay, so we have our A as a 20. Then what is our D? So remember I said for us to get D, you can get T2 minus T1 or T3 minus T2. So the difference between two consecutive terms. So this is going to be 23 minus 20, which is a 3. So our D is a 3. And then besides that, we have the last term, which last term in this case, we're just going to call Tn is 101. Now, for us to get the number of terms, how many, that will be the n in question. Okay. So from the general term, we have to say a plus n minus 1 into t. Okay, so where there's Tn, I'll have my 101, my a is a 20, plus the n, which I don't know, minus 1, and then I'm multiplying it by 3. Okay. Then whatever is left is just general algebra. So open this up, I'll have 101 is equal to 20 plus 3n minus 3. Guys, where you put the 101 doesn't matter, whether on the left or on the right, it will be just the same thing. Then 20 minus 3, that's going to be 17 plus 3n. Let me just push it that side, it's 101. And then I can move the 17 to that side. It will be a subtraction. So 101 minus 17. What do I get? What do I get? What do I get? People with calculators. It's 90 what? Get 90 now. But that is at 4. Someone saying it's 84. 101 minus 17. I don't know. Someone help us. Okay, so if we take what we've been told that it's 84, then we have to divide both sides by 3. So 84 divided by 3, we're having a 28. So in other words, we have 28 terms within this sequence. Okay. Then they're telling us that the even numbers are removed from the sequence. Calculate the sum of the terms of the remaining sequence. So We know that even numbers are those numbers that can be divided by 2 without a remainder. Okay. So an example, if 20 is removed, if 26 is removed, and then if 32 is removed, and so on. So what are we going to be left with? We're just going to be left with the 23. We're going to be left with the 29. And then we're going to be left with the 35, and so on and so forth. So these terms that are left will form a certain pattern of their own. Okay. But remember, we had 28 terms in total. So these 28 will represent half to be even and then half to be odd. So number one that we need to know how many terms are there is 28 divided by 2, which will be 14 terms that we're looking at. Okay, so from the 14 terms, we don't need to write all of them out and then add them. No, that will be a lengthy process. So from the terms that are left, we know that our A is going to be a 23. Okay, and then what is our D? Because 29 minus 23, that is a 6. Then since it is still arithmetic, then get to the sum of an arithmetic. We said it's n over 2 into 2a plus n minus 1 into t. So the number of terms, we said it's 14. So that is 14 over 2, open brackets, 2 times 23, plus the number of terms, we said 14 minus 1, and then we're multiplying it by 6. Okay, we know that 14 over 2 is a 7. Then 2 times 23, that is a 46, plus 14 minus 1, that is 13. And then when we multiply it by 6, we end up with, is it 78? That's what I'm seeing. Okay, that is a 78. Then you can just do this directly. So 46 plus 78, that gives me, I think it's 124. Then 124 times 7. 124 times 7, then I'll have my final answer as 868. So that is the sum of the remaining terms. Okay. Then 4.2. They want us to study the geometric series of x squared over 3, x cubed over 9, and so on and so forth. They want us to determine the nth term in terms of x. So when a question tells you that you must find something in terms of a particular variable, it simply means that your answer must contain that particular variable as well. They're not asking you to find the value of the variable. So the question was specific, it's geometric. We know that the geometric is given as a r n minus 1. Okay, then, okay, so our first term is x that we know. It's our a. What we need to determine is just the r. So we said for us to get the r, you can just divide. So it's x squared over 3. I'm dividing by just x, or just say times 1 over x. So which means my r is just going to be x over 3. In other words, I'm multiplying the previous term by x over 3. So my nth term Tn is going to be x multiplied by the r, which is x over 3 to the exponent. I'll put that in brackets. I can say n minus 1. That is enough. That is enough. Then 4.2.2. Determine the value of values of x for which the series will converge. So we said for a series to converge, it has to be geometric, which is now correct. And then we need the condition, which is -1 is less, the common ratio is less +1. But our common ratio was x over 3. So let's do the replacement. So -1 is less x over 3 is less 1. Then for us to leave x alone in the middle, just multiply through by 3, which means it's negative 3 is less x and is less 3. So that will represent the condition under which this series will converge. Alternatively, since negative 3 is less than x, which means x is greater than negative 3, but then x will be less than 3. You can also indicate it in that sort of format. There is no problem. 4.3 are telling us that the sum of n terms in a sequence is given by this. Then they ask us to determine the 23rd term. So T23. Remember what we said? That for us to get terms using the sum, we shall get the sum of the first 23 terms minus the sum of the first 22. Remember, we said Tn will be Sn minus Sn minus 1. That's what we said. So what we need to do, replace n with a 23 into this formula, and let's get S23. And then do the same with the 22, and then we get the S of 22. So if I find the S of 23, and just do it separately here, that's going to be negative, but 23 squared plus a 5. Okay, if I punch that into my calculator, that's 23 squared plus 5. That's giving me a very small value, which is negative 524. Then if I find S22, so where there's n, just replace with a 22. That is giving me negative 479. Okay, so do the substitution. So negative 524 minus negative 479. So that's going to be negative 524. Come on. Minus my answer. What do I get? So which means my term 23 is negative 45. So that's how you go about that. If you're given the sum formula, and then you need the term or the value of the terms, just subtract the sums. Number 5. Okay. The sequence 3, 9, 17, 27 is quadratic. Guys, in some cases, if you're not told the type of progression sequence or series, you have to investigate. Okay. You first check whether it's arithmetic, geometric, or quadratic, if it forms any of the properties that we talked about. Then I want us to get the nth term. So it's a 3, it's a 9, it's a 17, it's a 27, and so on. So we say that with a quadratic, we have two differences. So we need to determine those two differences. So the difference between 3 and 9 is going to be a 6. Remember, it's T2 minus T1. It's T3 minus T2. Then 17 minus 9, what does it give us? Is it 8? No, it should be 8. And then 27 minus 17 is a 10. And then for the second difference, we expect a common constant value, which is 2, 2, 2, 2, 2. Initially, when we started, we said we have to relate these two with, let me just take people back to the quadratic. Remember, we said we have to relate it to the 2a. And then the first value of the first term must be related to the 3a plus b, and then the first term of the quadratic must be related to the a plus b plus c. So if that is true, which means our 2a is going to be the same as 2, okay? And then solve or look for the value of a, which means a is a 1 when you divide both sides by 2. Then our 3a plus b is going to be equated to the first term, which is a 6. but our A was a 1. So replace A with a 1 and then solve for B. So 3 times 1 plus a B is equal to 6, which means B is a 3. When you transpose this 3 to the right-hand side, then we know that A plus B plus C should be the first term of the quadratic, which is 3. Our A is a 1, our B is a 3. We're looking for C. Let's give us a 3. So this is 1 plus 3, which is a 4. Subtract that side. C is a negative 1. So which means that our Tn is going to be 1n squared, which is just n squared, plus the Bn, which is 3n, plus the C, which in this case is a negative 1. So that is how we go about it. And that becomes our final answer. Okay. Five 5.2, what is the value of the first term of the sequence that is greater than 269? What is the value of the first term of the sequence that is greater than 269? Okay, so in this case, we know that probably 269 is not part of the sequence. Okay, but we need to find the value of the first term that is greater. We're going to have quite a lot of terms that are greater than 269, but what will be the first value? So what we can do, we can decide to find at what point will the terms be greater than 269. So which means I'm going to get the nth term and I'll indicate greater than 269. And then I'll solve for this, determine the n value. So that n value will represent slightly or approximately the value of what I'm looking for. Okay. So I'll say n squared plus 3n minus 1 is greater than 269. I can transpose that to my left. I'll have n squared plus 3n, that is minus 270, is greater than 0. Okay. So I can use my quadratic formula, or I could use just the factors. Two numbers I multiply to give me 270. Then when I add them, I get a 3. That could be a marathon for me to be using factors and what. But if I use the quadratic formula, what do I end up with? That needs to be the question. So let's say I have n is equal to negative b plus minus square root of b squared minus 4ac divided by 2a. So our b is a 3 plus minus, that's going to be 3 squared minus 4, the a is a 1, and then the c in this case with the equation is negative 270. Then I'm dividing it by 2 times 1. So the first n that I'm getting is negative 18. And then the second n I'm getting is a 15. So remember, since this whole thing is greater, which means n must be less than negative 18, or n must be greater than a 15. Okay, so what does this mean? If we get 15 and then substitute it into the general term, okay, what will it give us? It might give us the 269 exactly, okay? But then they're telling us that n has to be greater than 15. And the only term, or the first term that is greater than 15 is going to be T16, the 16th term. So this is going to be the first term that is going to be greater than 269. Okay, then I'm just going to say T16, and then I do the substitution. So 16 squared plus 3 times 16, and then minus 1. So 16 squared plus 3 times 16 minus 1. That gives me 303. So that is where the question wanted us to find the value of the first term that is greater. So it is 303. Because we know that term 15 is just 269. Okay, question number 17. So you don't mind about the number. They're telling us that the quadratic sequence 1, 2x minus 1, 5x minus 2, 25, and so on is given. This is quadratic. Then we need to determine the value of x. So since it is quadratic, remember the rule. There has to be two differences. Okay, that is that. Okay, let me find the first difference. So this term 2 minus term 1 is going to give me 2x minus 2. Then if I get this, 5x minus 2 minus that, that's going to be 3x minus 1. Let's do this. 5x minus 2 minus the whole of 2x minus 1. So that's going to be 5x minus 2x. This is a minus 2 plus a 1, so which is 3x minus 1. Then I need to find this. 25 minus the whole of that. So that's going to give me 27 minus 5x. Okay. Someone's asking, but how? Okay, that's 5x minus 2. All right, open that up. It's a 25 minus 5x. Negative, negative is a plus 2. 25 plus 2, that's a 27. So I can stop it. I can stop at that with the first differences, or you can go ahead and get all of this. Then for me to get the second differences, I have 3x minus 1 minus the 2x minus 2. So I'll say 3x minus 1 minus 2x minus 2. That's 3x minus 1 minus 2x plus a 2. So that gives me x plus 1. When I try to do the same here, 27 minus 5x minus 3x minus 1. That's going to be 27 minus 5x minus 3x plus a 1. So that gives me 28 minus 8x. So we know that the second differences have to always be the same or constant. So I'm going to equate this to that. So x plus 1 is 28 minus 8x. Then I'll transpose, move this that side. I have 9x is equal to 27. Divide both sides by 9, which means x is a 3. Okay. Then they want us to get the nth term. So if n is a 3, I can just quickly go and, because I know that all of this is going to represent my 2a. All of this is going to represent my 3a plus b, and then that one will represent a plus b plus c. So I'll say that my 2a is given as x plus 1, that is 3 plus 1, which is a 4, which means a is a 2. Then 3a plus b will represent my 2x minus 2, because 2 times 3 is a 6. 6 minus 2, that's a 4. But then if a is 2, then that will be 3 by 2 plus a b is equal to 4. And then b becomes a negative 2, because 2 times 3 is a 6. When you subtract from 4, you get a negative 2. And lastly, a plus b plus c gives us a 1. If our a is a 2, our b is a negative 2, what is c? So these two cancel out, and then c becomes a 1. Then I can easily write my Tn to be 2n squared minus 2n plus a 1. All right. 19, 19, 19, 19. We have a sigma notation. Okay. So sigma from t is equal to 0 up to t is equal to 99 is given as 3t minus 1. Determine or write down the first 3 terms of the sequence. So what we do in this case, just substitute t with these numbers, but we have to start with 0. So my first term, or our first term, is going to be 3 times 0 minus 1. The second term from 0 you go to 1, that's 3 times 1 minus 1. Then the third term is going to be 3 times 2 minus 1. So 3 by 0, that's a 0 minus 1. So the first term is going to be negative 1. 3 by 1, that's 3. Minus 1, that's a 2. And then 3 by 2 is a 6 minus 1. Then that's a 5. So these will represent the first 3 terms that they need. Then they need the sum. They want us to calculate the sum of the series. So by virtue of the equation or whatever is inside the sigma, consider this is a linear format. But let's not take that for granted. Let's try to prove it, whether we have the same difference. So if I added 3 here, I get a 2. If I added 3 here, I get a 5. So which means it's an arithmetic. Okay? So we know that with arithmetic, Sn is n over 2 into, we can choose to say, I don't know, I'm tempted to use the last term, a plus L. Okay? But then for me to get the L, I'll have to get the 99 or T99 or whatever number of terms are there, or the last term. So which means my L is going to be 3 times 99 minus 1. Let's see. 3 times 99 minus 1, that gives me 296. Okay. If that is true, we're also going to use the other format and see whether we get the same answer. So how many terms do we have in this progression? Remember, we said first with the number of terms, get the last point of reference, which is the 99, minus the starting point, which is a 0, and then you plus a 1. So in other words, we have 100 terms in this sequence or this series. So that's going to be 100 divided by 2 into the first term is -1 plus 296. I don't know what we get. That's going to be 100 over 2 into -1 plus 296. Then that is 14750. 14750. That's what I'm getting with this format of the last term. Now, what if I use the original approach of saying Sn is equal to n over 2 into 2 times a plus n minus 1 into d. Just want to see if I get the same thing. So the number of terms will still stay the same. That's going to be 100 over 2 into 2 times -1 plus 100 minus 1, that is 99, times the common difference, which is a 3. So when I do that, that's -2 plus 99 times 3. Okay, I'm getting exactly the same answer, 14750. So regardless of which approach you go for, you'll still get the same thing. All right, part B, that is the 7-mark question. Okay, they're telling us that the first 3 terms of the geometric will be given as, wait. Determine the first 3 terms of a geometric sequence. Okay, they want us to get the first 3 terms, out of which the 6th term is given as this, and then the 9th term is given as this. So in other words, our T6 is -3 over 16. Our T9 is given as 6 over 256. They want the first 3 terms. So remember, for us to work this out, it's going to be a requirement for us to get the value of A and then also the value of R. So this is a typical simultaneous equation type of question. Okay. So we know that the general rule or the general term of the geometric is given as AR n minus 1. So if we talk about T6, T6 is going to be given as AR to the exponent of 5, because that is 6 minus 1 to 5. Then where there is T6, I'll replace it with this. So that's negative 3 over 16 is equal to AR5. Call that equation number 1. Then I'll go do the same thing with T9. So T9 will be given as AR to the exponent of 8. Where there is T9, I'll substitute the 6 over 256 is equal to AR to the exponent of 8. I'll call this equation number 2. Then whenever we have a geometric, we normally prefer to use division to eliminate one of the unknowns. Okay. So it doesn't matter whether you take equation 1 divided by equation 2 or equation 2 divided by equation 1. There is no problem. So I'm going to say 2 divided by 1. Okay. So I'll have 6 over 256 over negative 3 over 16. This will be equal to AR to the 8 over AR to the 5. So as we can see, I'm trying to get the value of R first. So this A will cancel with that A. Then when I look at this, I have 6 over 256, but I'm dividing it by negative 3 over 16. You can quickly use your calculator in this case if you feel it's going to confuse your way. So that would be a negative 1 over 8 is equal to, when I work this out, I'll have R cubed. Because the bases are the same, you subtract the exponents. Then I'll be required to find the cube root on either sides. Okay. So which means my R is going to be negative a half. Our R is negative a half. Then having obtained the R, you can write it as negative a half or negative 0.5, no problem. Then we can find the value of A by using one of the equations, either equation 1 or equation number 2. So let's say I use equation number 1. My A is going to be negative 3 over 16 times 1 over R to the 5. Because I'm dividing both sides by R5 and then R5. Then when I do the substitution, that will be negative 3 over 16. Okay. But I'm multiplying it by 1 over 2, or just a negative 2. Does that even make sense? Don't want to do the wrong thing. It's 1 over negative a half. Everything is to the exponent of 5. Or you can just say 0.5, just to be on the safe side. Okay. So in this case, please, let's try to use the brackets so that the negative sign is not disadvantaged. So negative 0.5 is saying to the exponent of 5. So the A that I'm getting is just a 6. Okay, when I just punch this into the calculator. So now the question wanted the first 3 terms. So our A, which is T1, is a 6. For us to get T2, just multiply this by negative a half. That is going to be a negative 3. And then multiply it by negative a half, that's going to be 3/2. Yes. So those are the first three terms of this sort of sequence. Okay, if there are any queries, any questions, any suggestions, just feel free to put them in the comments. So I'll try to get back to them. Then next question, they're telling us if we're given the sigma notation from n1 up to infinity, and it gave us this expression inside. Write down the first three terms in terms of k, which means our terms must have k with them. So what we say we do, just substitute n with the 1. So if I make n1, that's going to be 3 minus 2k. If I find the second term, it's going to be 3 minus 2k, but squared. And then the third term is going to be 3 minus 2k, but cubed. So that is it. Then determine the values of k for which S converges. So remember the condition that we said, that for any sequence or any progression to converge, a common ratio must be within these limits. Okay. So we need to find our common ratio in this case. So if we get term 2 divided by term 1, we're going to end up with a common ratio of just 3 minus 2k. So let's replace this or substitute this with r, so that we have negative 1 is less 3 minus 2k is less a positive 1. Then how do we solve this? We have to transpose the 3 to that side and then that side. So the signs have to be just the same as you do the transposition. It's going to be, since the 3 is positive, then we're going to subtract. We're going to end up with negative 1 minus 3, which is negative 4. We're going to be left with just the negative 2k in the middle. Then it's going to be 1 minus 3, which is a negative 2. And then we need to get rid of this negative 2. We divide through by negative 2, divide through by negative 2, divide through by negative 2. So whenever we divide inequalities with a negative, the signs change. So this is going to be a positive 2 is greater than a positive k is greater than a 1. So this can be our answer. Alternatively, you can switch it and say 1 is less k is less 2. So those are the formats. It's either you write it this way or in this format when they are switched around. Okay, so that is 22.2. Then 22.3, they're telling us that, okay, we are assuming that S is converging, which is correct. And we are given that K is 1 whole number and 3/4. Can we calculate this thing? Can we calculate this thing? So they are technically giving us the value of K. But what do they want based on what we give it? They are indirectly asking for the sum to infinity. Okay, they want the sum to infinity, since we're starting with 1 and ending with the infinity symbol. So we know that sum to infinity is given as a over 1 minus r. Remember, our a was a 3 minus 2k. Okay. Then what we need to do is just replace k with 1 3/4. So you can change this to an improper fraction, which will be 7/4. I think, because it's 1 3/4. 4 times 1 is a 4 plus 3, that's a 7. But over the denominator, which is 4. So if it is 7/4, which means our a is going to be 3 minus 2 times 7/4. What does that give us? 2 times 7/4. I'm ending up with negative 1/2. All right. So A is negative a half. Then I need to find the R. Remember from what we said, our R was that entire thing, the 3 minus 2k. Okay. So 3 minus 2k, which means it's going to be just the same thing. It's 3 minus 2 times 7 over 4, which is also negative a half. All right, that's the substitution. So that's going to be our A, which is negative a half. I'm dividing it by 1 minus negative a half. Okay. So simplifying this to negative a half, what do I get by the bottom part? That is 1 plus a half, which is 3 over 2. Positive. Okay. And then when we do the division, when we do our division, I'm getting negative a third as our answer. Someone asks, is it possible to have the sum as negative? Yes, it's highly possible. Looking at the patterns or looking at the terms themselves. Okay. If majority of the terms are negatives, then we expect the sum to be negative. But in this case, chances are high we're going to have some positives and the negatives. So there's a high likelihood that we shall have a negative. All right, question number 23. I think we're almost there. So 23, they're telling us that we're given a quadratic that is having a third term as 28. Then the general term of the first differences is given as this. Can we determine the nth term of the quadratic? So we know that this first differences will be arithmetic, which is true. So let me assume I have my T1 here, my T2, which I don't know, and then my T3, which is a 28, and then I have a T4, and so on and so forth. The number that comes just here will be the first term of this rule. So where there is n, I can put a 1. So negative 6 times 1 plus 5, that will give me a negative 1. And then my second difference here, I'll use a 2. So negative 6 times 2, and then plus 5. That will give me a negative 7. Okay. And then the next one, what will it give us? If I use a 3, that's going to be negative 6 times 3 plus a 5. That becomes a negative 13. So which means that if I get negative 7 minus that, I get negative 6. That's my second difference. Okay. So what do we have? We have this last part that represents the 2a. We have the part that represents the 3a plus b. What we don't have is the first term, the quadratic. But that is not a problem because we can just maneuver around and move backwards with the 7 and 28 and end up with that. So if I'm now moving backwards, instead of subtracting, I'll have to add. So 28 plus 7, that's going to be a 35. And then 35 plus 1, that's going to be a 36. So which means my T1 here, the A plus B plus C, will be represented by 36. Then I start. 2a is a negative 6, which means a is a negative 3. And 3a plus b is negative 1. Replace the negative 3, that's a negative 9, plus b is negative 1, which means our b is going to be just 8. And I transpose the 9. Then our a plus b plus c gives us a 36 that we saw. If our a is negative 3, our b is 8. What is the c to be 36? So that and that will give us a positive 5. Take that side. So c is a 31. So which means that our Tn is going to be negative 3n squared plus 8n plus 31. There we go. Okay. Then question number 24. Let's see. The following sequence of numbers, quadratic, first differences of the above, also forms a sequence. Determine an expression for the general term of the first differences. Okay. So these numbers, these are the quadratic terms. So negative 3, negative 2, negative 3, negative 6, negative 11. Does it make sense? I don't know. Let's see. Negative 2 minus 3. That should be a 1. Then negative 3 minus 2. That should be a negative 1. And then negative 6 minus that's negative 3. And then that is going to be a negative 5. Look at this, a negative 2, a negative 2, and then a negative 2. So they want us to get the general term of this. So since it's arithmetic, we can just use the arithmetic. So a plus n minus 1 into d. So our first term is a 1. That is n minus 1. The common difference is negative 2. Then we just need to open up this bracket. So that's going to be 1 plus negative 2n plus 2. Then 1 plus 2, that's a 3, which means the Tn is just going to be negative 2n plus a 3. Then part B, calculate the first difference between 1/35th term and then 1/36th term of the quadratic. So what this means is that if you look at our sequence, the first term of the first difference is between T1 and T2 of the quadratic. The second term is between T2 and T3. The third term is between T3 and T4. Now, if a question wants the first difference between 135 and 136, so they want us to determine the T135 of the first difference. Okay, so from here, I don't know if that makes sense. So T135 of the first difference will be negative 2 times 135 plus a 3. Negative 2 times 135 plus a 3 is giving me negative 267. So this is the difference that we're going to get between T135 and T136 of the quadratic of the main sequence. The difference is going to be negative 267. Okay, and then determine an expression for the nth term or the general term. Okay, so we have negative 2n. And then a is a negative 1. And 3a plus b. What was the first difference? It's a 1. That's a negative 1. So 3 by negative 1 plus b is a 1, which means b is a 4. Then a plus b plus c should give us the first term, which is negative 3. Okay, so our a was a negative 1. Our b is a 4. The c we don't know should give us negative 3. So this will give us a 3, which means c is going to be a negative 6, which means the Tn is going to be negative n squared plus 4n minus a 6. Okay, but they want us to explain why this sequence will never contain a positive number. Why can it not contain any positive number. So usually with questions of this nature, we try to look at the general term, okay? Because we know that negative n squared. So when you square any number and then introduce a negative part of it, or you introduce a negative sign, the number automatically becomes a negative. Okay? Then when you have 4 times the position of the number, that's going to be positive. But then the overall result that we get here, in most cases, it's going to be smaller. If now we bring in the negative 6, because like we are having a negative n squared, and then we're having a negative 6, trying to sabotage the 4n. You can try it. If n is 1, that's going to be negative, and then 1 squared, which gives us a negative 7. But then if n is 1 here, that's 4 times 1, which is a 4. It's going to be negative. If you try with 2, it's going to be the same thing. 2 squared, that's a 4. And negative 4 minus 4, that's a 10. When you put a 2 here, it's going to be 8. So we can simply say that the product, now we can say the 4n gives a smaller value compared to a negative n squared minus 6. Hence, most of the terms or all the terms are going to be negative. Okay, 25. They are telling us that find T15 for an arithmetic sequence where T3 is that, and then T6 is that. Okay, so the question is going to be, what is the I representing? What will the I represent? If T3 is given as that, and T6 is given as that. Okay, let's see. Let's see. Since it's arithmetic, I'll keep the I as well, which means our T15 should also have the I. Okay? So it's A plus N minus 1 into D. Then if we don't know the value of A, we don't know the value of D. So when I talk about, let's say, T3, that's going to be A plus a 2D, because the N is 3 minus that. Then when I look at T6, that's going to be A plus a 5D. So where there is T3, I'm going to replace that. Where there is a T6, I'm going to replace that. So that's going to be negative 4 plus 5I is equal to A plus 2. Well, I could take this to be my equation number 1. And then where there is T6, I'm going to substitute that. So it's a negative 30 plus 11I should give us A plus 5D. That's equation number 2. Then I can choose to subtract the 2 equations so that I can find the value of D and also try to get the value of A. So let me say equation 2 minus equation 1. Okay. So the A's are going to fall away. Okay. 5D minus 2D, that's going to give me a 3D, is equal to, I'm going to have 11I minus 5I. That's going to be a 6I. And then negative 13 minus 4. That's like negative 13 plus a 4. Is that a negative 9? Let's just be sure. It's negative 9. Then divide both sides by 3, which means this 2i minus 3. Then for me to get my a, I need to substitute this d into one of the equations. Let me use equation 1. So from equation 1, 4 plus, it's a negative 4, sorry, plus 5i is equal to a plus 2 times 2i minus 3. I will transpose this to that side so that I have a being the same as negative 4 plus 5i minus 4i plus a 6. I move this bracket aside, so it will be a negative bracket. Okay. And then when I try to open it up, I end up with that. So 5i minus 4i is just an i. Negative 4 plus 6, that's a 2. So this is our a value. The question wants T15. We know that T15, oops, that is too light. No, it's given as a plus 14d. That's from the general term there. So our a, we said, is I plus 2. And then 14 times the d, which is 2i minus 3. And then we just have to simplify this. So this is going to be 28i plus 1. That gives us 29i. 14 times 3, that's going to be 42 negative. Plus 2, that's going to be negative 40. So that is my T15. Then part B. First part B. For which values of x is this convergent? So remember, all we need in all of this is just the common ratio and the condition. So the common ratio, we can get the 2 into 3x minus 1 squared. I'm dividing it by 2 into 3x minus 1. So this cancels that. This kills one of the brackets. So that our ratio is just 3x minus 1. So negative 1 is less r is less 1. Negative 1 is less the 3x minus 1 less 1. So move the 1 first. When I move this one that side to be a plus, I'll end up with a 0. It's less 3x. When I move the one that side, I'm going to end up with a 2. Since it's going to be plus 1 and then plus 1. Then divide through by 3. So 0 divided by 3 is going to be a 0. Is less x is less 2/3. So those are the values of x between 0 and 2/3. Then the second part, if sigma k is equal to 1 up to infinity is given as that, they want us to calculate the value of the sigma. So whenever you have calculate sigma, you want to get sum. And in this case, since our last point is the infinity, which means we have to get the sum to infinity, which is a over 1 minus r. So if x is a half, we are required to find the value of a. Okay, so that's going to be 2 into 3 times a half minus 1. 2 into 3 times a half minus 1. That gives us just a 1. That's what I'm getting, guys, 1. Then I also need to get my common ratio, which is 3x minus 1. It said r is 3x minus 1. So 3 times a half minus 1. So our r becomes a half. And then let's do the substitution. So that's going to be 1 over 1 minus a half. And then our sum to infinity just becomes a 2. Because it's going to be 1 over half, which is a 2. All right, then question number 29. Telling us that the first term of an arithmetic is given as a 6, and then the common difference is a 3. Find the formula for the nth term. All right. So Tn is a plus n minus 1 into t. Just substitute. Say 6 plus n minus 1, the difference is 3. Open up this. 6 plus 3n minus 3. So when you simplify, you're going to get 3n plus a 3. That's what they wanted. Then they want the value of the 50th term, T50, going to be 3 times 50 minus 3. And that is 147. I hope so. Correct. Then find P if, and I put the sigma notation. Find P if this was the gives us this. Okay. Guys, what do you think? Okay, so what I'll do in this case, I'll first of all try to determine the type of sequence it is. But is it going to make sense? Find P if the sigma is given as that. Now we can trace. If we're starting from P, so our first term is going to be 3P minus a 4. Okay. Okay, so if our first term is 3P minus 4, I can determine the number of terms within this progression. Remember, we said the last part, which is 2P plus 3 minus P plus 1. So that cancels that, or reduces that. I'm only left with a P plus 4. So which means our n, the number of terms, will be P plus 4. Now, we know that this is going to be an arithmetic. How do we tell about that? When you look at what is fed into the sigma, this is a direct arithmetic kind of progression. Whereby now I'm going to take my common difference. I'll assume my common difference. If I take it to be a 3, will it make sense? Because now I'll be assuming that I have just 5 terms there. If I take the common difference, no, let me not stress with the common difference. I can look for the second term, which will be probably P plus 1. Okay, so that will be 3 into P plus 1 minus 4. So what will this give me? It's a 3P plus 3 minus 4, which is 3P minus 1. So this is my first term. This is my second term. When I try to subtract these two to get the difference, we're going to end up with a 3 as well. So which means it just confirms my intuition that D is going to be a 3. Now, if we have our A as this, and then our D as a 3, then we can try to work out where this is. Okay. So the sum of how many terms? P plus 4 is equal to n over 2 into Should I use A plus L? I think that is better. This sum is going to be equated to the whole of that. Now, if I get my L, which is the last term, which is 2p plus this, so it's going to be 3 into 2p plus 3 minus 4. That's going to be 6p plus 9 minus 4, which is a 6p plus 4. Do the substitution, that is p plus 4 over 2. Into our first term, we said it's a 3p minus 4. And then plus the last term, which is 6p plus 4. When I simplify just the sum of these, I have my p over 4. So p plus 4 over 2. Simplify what is there, 3p plus that. That's a 9p. This and this just cancels out. And then I can do the multiplication. That's going to be 9p squared plus a 36p over 2. Now it is this that I must equate to the 4p squared plus 20p plus a 37. Okay. Now for me to eliminate the denominator, I can multiply through by 2. So I'm just going to be left with 9p squared plus a 36p is equal to 8p squared plus 40p. What is 37 times 2? That gives me 74. And then I'll transpose and create a general equation or a standard equation. So if I move everything to the left, that's going to be just p squared. 36 minus 40, that is minus 4p, and that is minus 74 is equal to 0. Then what will happen? I can just use the quadratic formula, or I can do the factorization straight away. Okay, so I know that my A is a 1, my B is negative 4, and then my C is a 74. Okay, if I put that into the calculator, I'm getting quite a lot. It's either P is 2 minus root 7, 8, or P is plus 2 plus. Does that even make sense? Does that make sense? So if T is a 3, okay, let me do this. Let me just confirm with that other approach of the n over 2 into 2a plus n minus 1 into d. So we have p plus 4 terms over 2 into 2. Our a is 3p minus 4 plus n. How many terms are we looking at? P plus 4. We subtract 1, then we multiply by 3. So 4p plus 4 over 2. Open brackets, that is going to be 6p minus 8 plus 3p plus 9. Let's just confirm and see if we're going to have the same thing. So 4 plus p over 2 is equal to this and this. I have my 9p. This and this is a plus 1. So where did we go wrong in this part? Because it tells us that we went wrong somewhere. Because 3, that is 6p plus 9 minus 4. So guys, I'm going to ask for your forgiveness. Let me just try to redo this thing. without any shortcuts now, because P has to be like a whole number. The fraction doesn't make sense. So which means I did something wrong somewhere. Might have messed up somewhere. Okay, so let's see. Okay, so we said we have P plus 4 over 2 into 9P plus 1. Okay, this should be equated to 4P squared plus 20P plus a 37. So multiply through by 2. As I try to open these brackets, I have 9P squared plus a P plus a 36P plus a 4 is equal to 8P squared plus 40P, we said plus a 74. Then create a standard solution, move everything aside, that's going to be P squared. So this and that, that's a 37P. I'm subtracting a 40P, that's a minus 3P. And then 4 minus that, it's going to be a negative 70. Does it make sense? Yeah, we're getting some. I feel it. Because now it's going to be 10 and 7. So I'm going to say P minus 10 and then P plus 7 is equal to 0. So which means either P is a 10 or P is a negative 7. So those are the two values of P. They said value of values. They just said find P. So these are the possible values that I'm getting with P. So guys, that is that with that question. 33. It's okay, we can try it. Where they're telling us that we have an arithmetic given by these terms. But the arithmetic part is formed by the first 3. So which means from here up to here is AR. And then the last 3 are forming a quadratic. And we show that X is a 7. So we can just focus on the arithmetic version of it. And let's try to get the differences, because the differences have to be the same. So we have 2x minus x, that's going to be 3x. Minus 11 minus 1, that's minus 12. Then x minus 2x minus x, 5 minus 11, it's a 16. And then I'm going to equate that. So 3x minus 12 is equal to minus x plus 16. And I move that side, it's going to be a 4x. I move this one that side, it's going to be 28. Divide by 4, divide by 4, x becomes a 7. Just the way they want it. Then hence determine the values of the first 2 terms and the common difference of the arithmetic. So if x is a 7, which means T1 is going to be negative 6, because it's 1 minus 7. Then T2 is going to be 2 times 7, that's 14 minus 11, which is a 3. Then our common difference, we can say negative x plus that. So negative 7 plus 16, that's just a 9. Just substitute into what you already got. That's the meaning of the hence part. Then calculate the general term of the quadratic. So with the quadratic, they said the last 3. So which means the T1 of the quadratic is going to be 7 plus 5, which is a 12. And then the T2 is going to be 3 times 7, that's 21 plus 2. That's a 23. And then T3 is going to be 5 times 7, that's 35 plus 3, which is a 38. And then we determine the differences. It's going to be 11. And then that's going to be a 5 and 1. And then that's a 4. Okay, so we know that 2a is going to be a 4. A is going to be a 2. 3a plus b is 11. If a is 2, which means b is a 5, because 11 minus 6 is going to be a 5. And then now a plus b plus c should give us a 12. 2 plus 5 plus c is a 12. That's a 7, c is a 5. So Tn is going to be 2n squared plus 5n plus 5. Okay, I think this should be our last question. There's a lot, guys, no? But we can just do only a few, as long as you get an idea of what exactly is going on. Okay, so I'll do 34 as my last. So they are telling us that the sum of a certain number of terms of an arithmetic is given as this. So how many terms must be added to give a sum of this? So where there is Sn, we're going to use negative 500. So negative 500 is equal to n over 2. Why don't we just open this up? Just going to set that 5n over 2 minus 3n squared over 2. Multiply through by 2. Negative 1,000 is equal to 35n minus 3n squared. Then you can regroup, create a standard solution or equation. Minus 35n minus 1,000 is equal to 0. And then you can use your quadratic formula to determine the value of n. So as you get in your n, remember, n should never be a fraction, and then n should never be a negative. Okay. So I'm getting two values. So my first n is negative 40 over 3, which means n cannot be that. Or my n is going to be 25. So which means we have 25 terms that we're going to add together to give us that. Then they're telling us calculate the value of the term that is closest to negative 58. The value of the term that is closest to negative 58. Okay, so guys, what do you think? Because we need the term itself and not the sum. The term and not the sum. Any suggestions on how we go about this? Okay, so one can start by looking at the general term of the arithmetic itself. That is, if you have to find the A and the D and all of that. So let's start by finding S1. The first term, that's going to be a half into 35 minus 3. So that's 32 divided by 2, which means the first term is 16. Then S2 is going to be over 2, which is a 1. Then 35 minus 6. Okay, 35 minus 6 is going to give me a 29. So what is our difference? What is 29 minus 16? Gives me a 13. Okay, so if I find the general term, Tn is going to be 13n plus a 3. Okay, if I use the A plus N minus 1 into D, which is now a 13, and then now A is a 16, I'm going to end up with this. Then if I equate this, I don't know if it's going to make sense. It's going to make sense. No. Something is off. Something is off. I can feel it. I can't see it. T2 is not 29. Because we said 35 minus 3 is 32. That's for the first term. And the second term, we said 35 minus 6, which is 29. Okay. So this 29 is the sum of the second term of the two terms. And for us to get term number 2, we subtract 29 minus 16, which is a 13. Yes. So that is becomes a negative 3. Okay. Then if that is true, then we know that the general term is going to be negative 3n plus, is it going to be 19? Because if this is a 1, then that is that. If this is a 2, which is perfect, then I can equate this. So negative 3n plus 19, I'll equate it. I said closest to that. I'll just equate it to negative 58, and then I'll see. You can use even the inequality greater or equal to or less or equal to, something like that. Then I'll move the 19 that side. So I have negative 59 minus 58 minus 19. So that gives me negative 77. And then I'll divide by 3, negative 3, which means I'm going to have 25,666 and so on. So what this means that if I get negative 3 times a 25, it's going to give me negative 75. But if I have to add a 19, I'll get a negative 56. Let's see, what if we use 26? So negative 3 times 26 plus 19, I get a negative 59. So the question is asking, give the value of the term that is closest. So 25 is going to be a bit far away from negative 58. And the closest one is going to be negative 59. So which means T26 is going to give us that. Okay, guys, so that is that with sequences and series. Please just get as many questions as you can and do the practice. Okay, the concepts are just the same. And remember, this question carries plus minus 20 marks. Okay, so it's usually 20 plus minus 5, somewhere there. So we believe, and we strongly believe, that these are marks that any grade 12 learner shouldn't miss. Okay, thank you very much. Let's meet in the next lesson.